going to start the recording now. All right, then welcome everyone to this TS session of DL GenAI Theory course. In yesterday's session, you have seen the theoretical portion of week 1 and 2, a recap of it. In today's session, we will be having a hands-on session on PyTorch, basics of PyTorch, and how to develop your first neural network model. And if time permits, we will also see a demo of and a working DL model, right? So I'm going to start. I'm going to share my screen. Please let me know if it's visible. Is my screen visible to you, to everyone?
Yes,
Yes,
sir.
yes, sir. Visible, sir.
Okay. So yes, we are recording the session. Um, So what we are doing here is, so what we are going to do today is we will be building a neural network model by ourselves using PyTorch as the framework. But before that, just a recap. Whenever you are going to develop a neural network model, I want you guys to always think of this kind of, mental model, and then go ahead and develop your neural network. There are three building blocks basic. If you are not speaking, please mute yourself. So first step will be there are three layers, three basic types of layer. One is the input layer. So input layer is basically um, the through which you will be sending your data to your model. Now one key change from your one key change from the basic ML model to deep learning model is in your traditional ML model, the data is in tabular format. So you have rows and columns, right? And you send that entire data to the model. Here, these are the, you can say, the nodes, right? These are input nodes. This node corresponds to the features you have in your data set, meaning the it means whatever attributes you have in your data set, these corresponds to those features. All right. And the the main change here is you send only those features to this through this data, through this input layer. So and that too in for every data point. So you take one row from your tabular data, you send that row by features, right, from this in through this input layer. Then you have this hidden layer. Hidden layer is it's not like only one layer. So whatever comes after input layer, whatever comes between input and output is known as hidden layer. I, someone is, yes, Mayank, go ahead.
Sir, will this session be recorded?
Yes, yes, Rohit.
Actually, it is not started, sir. Maybe
We are
record.
recording locally. Yeah. Any other questions?
Yes, sir. I have a doubt. If a layer has 10 neurons, so sir, does each neuron have different activation functions or the same?
For each layer.
No, for each neuron,
Oh, for each
each
neuron.
same layer.
For each neuron that you can do, but we don't usually do it because essentially we are saying that for, suppose for this you take ReLU and for this one you take something else, tannage. Is it the question?
Yes, sir.
We
Relu
can,
only.
you can do it. No one is going to stop you, but but when because the only problem is we do that entire calculation by vectorization, right? So while calculating the forward propagation and backward propagation, it will be extremely difficult for you to understand where to apply tannage, where to apply ReLU. To make it simple, we for every layer the activation function remains the same. Suppose for this layer we use ReLU only, for this layer you use tannage or something, whatever you think is suitable. All right. Theoretically it is possible, but practically for computational purpose we don't use it. All right. Any other questions?
Normally we use ReLU for all the hidden layers, right? For the
No,
output, huh?
yeah, whatever some that depends on what kind of use case you have. Relu, people actually use it sometime, but it's not like that's the standard. You can use any kind of activation function, and Relu even introduces some issues as well that you will
Okay.
see in the future, weeks.
Okay.
Yes, Ashish.
Sir, I joined late, sir. I mean, just now. What are we discussing today?
We'll be having an hands-on of the PyTorch model development. Hands-on of PyTorch and model development.
Sir, it is week, which week?
Week 1 and 2.
Okay. Sir, one more thing, sir. Yesterday's TA session recording, I missed the session. Can you
It
give
will
the
be
access?
recorded.
I
Yeah,
requested.
it will be shared. It will be shared by today, I think.
Okay.
Okay, so so far we have discussed about the input layer. So inputs, these nodes corresponds to the features you have in your data set. These are the hidden layers, and then comes your output layer, right? These are the output layers you have. Sorry, this is the output layer where you will get your output basically, right? Now the typical flow is you flow your data, you send your data from input layer to output layer through your hidden layer. That is the feed forward, feed forward flow, and then you calculate the loss at the output layer. So you will be getting your prediction from here, and you will calculate the loss. So you will create some, you will incur some loss. Then you will do backward propagation. So you again then you start calculating the gradients for this particular to this through this direction, right? And then you will update the weights and biases for each layer, and that's how you can kind of optimize the neural network. All right, so first will be the feed forward flow, then you calculate the loss, and then you calculate the gradient, and then you change the weights. So basically gradient descent. All
Sir,
right.
when we will calculate the loss and do gradient and back propagation in hidden layer or after output, that is not.
We calculate loss for every layer to update the weights of the entire network. But yeah, and forward propagation is through the entire network, right? That's how we calculate the forward. So if you do not pass the data till your last layer, you will not get the output, right? So that's feed forward is for the entire network, backward also is for your entire network, but you can actually do it partially, but that let's not go there for now.
Sir, if we have n hidden layers, then we will feed forward to all n and then we will calculate the loss
No,
after
no,
n.
loss comes before calculating the gradient, right? So you start by calculating del L by del W, right?
Okay, it will happen in each
So
layer
first
or
you
after whole layers, that
no,
I
no,
didn't get.
no. Yeah. So you are asking like you get the output from this output layer, then you calculate the loss, and then you start calculating the gradient for each layer, right? And
No,
then
I said before before giving the output, like at the end of hidden layers.
I'm not getting your question.
Sir, we will do all this math in hidden layers, no, sir.
For every
We will
layer,
go
for
feed
every layer,
forward.
yes, for every layer that you have, suppose for input to hidden, this has its own W, right? And all the hidden layers will have their intermittent W's. So if there are two layers, this also will have W, and hidden to output will also have its W's and B. So wherever you have any parameters like W's, B's, and some other parameters, you will have to perform the gradient descent and change the weights and biases. So for that you will have to calculate the what you can say, the gradient descent. Sorry, gradients.
Okay, sir, that I got, but we are doing this gradient descent calculation where after in a layer or at the end of all hidden layers. That's my
Oh,
question.
acha, got it. So yeah, in deep learning in a practical setting, you do it vector like you calculate all the gradients, right? And then you change or update all the weights at one go, right? Because it's a vectorized operation. But if you are going to calculate it, manually, if you are going to calculate it by hand, then you have to go layer by layer. So first we'll update the W here, and then we'll update the W here. So one by one you will calculate the W, change it. So in the next epoch you will then use the updated weights,
Okay, sir.
right? So yeah, if I'm not sure if the calculations were done in the yesterday session, but what we can do is in one session we can actually take one numerical problem and show you how to solve this back propagation by hand. This will make this concept more clearer, I think. We can arrange one session for that, right? So it will look like this, the neural network. So these are called fully connected network because every neuron will be connected with every other neurons, all right? And if all whenever you see any weight edge, this edge will have its parameters W and B, weights and biases, all right? Biases can be 0 or something. Just a recap, you have already seen this in yesterday's session, so I thought of giving a recap of it. Now we'll be going for the hands-on session now. Um, so first we'll see the basics of PyTorch. You already have a very detailed notebook available inside this particular resources section, PyTorch fundamentals and PyTorch workflow. You can go through it, but in this session we'll be using this particular notebook, all right? I hope this is visible. So tensor, so far you have seen list as a data type, and then probably numpy array as well. Now there is one more data type that you have to use throughout this course and even in the project course, that is tensor, all right? So uh, this is the tensor. There are three types of typical tensors. You can say that this is the rank 0 tensor, that is scalar value. Then you have rank 1 tensor, that is a vector, a row vector or a column vector that you have already seen. Rank 2 tensor is the matrix meaning rows and columns. And then if you stack up a lot of this type of rank 2 matrices, you will get a rank 3 tensor like this, right? So that's how a typical tensor will look like. So there will be so you can think of it like an image, and each the image has RGB channels, right? So this is for, suppose this is R, then we will have a similar matrix for G, and then we will have another matrix for B. These are the three color channels, right? And if you stack up these three channels, you will get one image, right? One colored image. So you can think of an image as a tensor, and that's how you can actually you have a mental model of it, all right?
Is it the same rank with what we learned in the matrix, the same rank calculation type of
Yes,
thing?
yes. Same.
And what is the difference between rank and dimension, which say zero dimension or zero rank? What is that?
Even I have to go back and visit it, but
Okay, fine.
yeah, you can check it.
No
Uh,
required to know about the depth of this rank and
no,
dimension like
for
that,
now
right?
you can skip that part.
Okay, fine. Thank
Yeah.
you. Please.
Sir, can we visualize higher order than three, or
Mm,
are those just abstract?
those will be abstract. You cannot visualize it, but it's possible. All right. Now I'll be even like explaining a three rank matrix or even three dimensional thing becomes too difficult, right? Sometimes. So higher order is not at all possible. All right. Now PyTorch, we will be using PyTorch as the framework for developing deep learning models. There are other framework. There is another very popular framework called TensorFlow. But I would strongly recommend you to learn PyTorch first and then go with TensorFlow, because PyTorch is the de facto standard nowadays, right? If you want to go with for any state of the art models, right? Now this is the so we'll be starting with the PyTorch basics. Uh, so how first we let us see how to develop how to create the PyTorch tensor using some basic operations. We have already seen how to this is a Python list, right? Suppose I want to create a tensor of this format 1 2 3. We can also create tensor from numpy array. This is a numpy array. You can see that I have created a numpy array of 4 5 6. So from this we can create tensors very easily. We just have to call torch.tensor if it's a list or array, and if it's a numpy array, then the operation is torch.num from numpy. Alright. So if I just
So this notebook is the same whatever given in the resource all
no,
the
this is
course
a separate notebook.
also
It will be
separate.
shared.
You will share this one also, no?
Yes.
Okay, fine. Thank you.
Just give me a minute. Right, so we have created our first two tensor. One is TA and one is TB. All right, and we can see that A and B's are actually A was not a tensor, right? Not at all a tensor. It was a list, right? Now we have converted from it. We have converted a tensor. Torch.isTensor. All right. PyTorch also provides some inbuilt methods to create some special tensors like torch.ones or torch.zeros. So if we call torch.ones, it will create, and then you have to provide the shape of the tensor, right? Shape meaning how many rows, how many columns, or if you want a higher rank tensor, that also you can define, and then you can actually create a tensor like this. How will it look like? So if I just print it, it will be a tensor of all ones. Can anyone tell me why is it required? Like why do you even have torch.ones or torch.zeros? It's all ones, right?
To actually we can avoid the sparse matrix
Exactly. Actually,
because we suppose we have only one data, then other will be a sparse. So for this purpose we can use one, right?
no, for sparse, you need zeros, right? Where you have to put zeros, that also you need to map. The
Is it?
right, but the actual reason is this type of matrices, this type of tensors are required. Suppose you are actually creating a neural network, all right,
Hmm.
and you
Hmm.
have to initialize your weights. Then you can initialize weights, or you have to initialize a tensor with all ones. You don't have to write these many ones for now. Then you just write torch.ones, and then you can just provide the shape of it, right? We don't initialize weights with all the same values. We can also initialize it like this. Uh, suppose So what I have done here is I have created a random. I have created a tensor with random numbers, right? And the shape of it is 2 rows and 3 columns. now I can actually use this as my W matrix initialized weights for my neural network, right? So that's how Torch gives you a lot of utility out of the box, which you can use for model building. All right,
What's the difference between this RAND and RAND-N? RAND-N.
we can actually see it. Torch.
Okay. Both are different, na? RAND 2, 3 and
Uh, no, actually, Torch.
torch.rand and torch.randn. What is the difference between this?
Sir, rand gives 0 to 1 values and rand n
Yes,
give random value.
yes.
Okay, that is positive only, it covers negative also.
Yes,
Correct.
this is negative. This will also give you negative values.
Okay, that is 0 to infinity, they were minus 1 to
Yes,
infinity. Correct. Okay.
yes. Now
Sir, why we have ones feature, sir? Can you tell that? I didn't get.
you can actually suppose you want these are actually some basis for calculation. You can actually create a lot of, suppose you want to have a just a tensor that you want to multiply with some other numbers, then you can actually use torch dot ones and then you can multiply it with other values. It will give you tensors of all twos, all threes, all tens, whatever numbers you want, and that gives you an utility of.
Okay, sir.
But we don't usually initialize our network with all ones, all zeros, because that may lead to a faulty training. So instead of that, we initialize our weight with this type of random matrices.
Okay, sir.
All right. Now we'll be performing some basic shape manipulation. So suppose this is the tensor. So what we can do is we can actually perform transpose of it. Transpose is one operation that we have to perform throughout this entire course, not this course, but throughout your entire deep learning career. So what we can do is we can write torch.transpose, and we pass our first argument will be the tensor that we want, and then the these two will be the axis that will be interchanged. So I want to interchange 0 with 1, right? And then if I do this, so this is my 0th axis, right? And this is my first axis. I will interchange, so 5 will come here and 3 will come here. And if I do this, then see t dot tr is my transpose matrix tensor. We can also do the same by using,
This is which axis? What do you mean by axis? The column and rows is the axis or different kind of thing is that?
yes. You can think of axis like column, rows for now. If
So
you are
0 is row and 1 is column.
yes, for now.
Okay,
But if
for
you
now.
but if you go to very higher dimension, like if it's a you have this RGB kind of a setting, right? Then you cannot
Mm-hmm.
say rows and column, because one more will be coming before that. If it is in 2 dimension, or you can say 2 dimension, then you can say this is your row and this is your column, and these are axes.
Okay, if it is more than one dimension, the 0, 1, 2, 3, 4, like it will be there.
Yes.
Okay.
So another way would be to do this kind of a thing. TR, it is also available in NumPy. So the same thing is available here. Dot T will give you the transpose of it. Okay. Same thing we are doing here. We are creating a zero matrix, tensor, and then we can just
There's any kind of that capital T and transpose both are the same thing. Anything you can use, right?
yes.
Okay.
Dot transpose is a much more powerful. Suppose it's like you have a
Because we are not giving any parameter in capital T.
yes. Suppose it
So
is in this format, height and width.
batch height.
So now what you can do is with transpose you can interchange height and width only. Just keep the batch unchanged. All right. and you can change batch and height with transpose. That kind of flexibility is not available in .t, but this is much more easier to write, right? So if you want a very flexible and you want more control over how you perform the transpose, you should use torch.transpose. If you know that what you are doing and you know that it will not break anything, you can use this kind of thing.
Okay.
All right. Reshape also you can do. You have already seen in NumPy that if suppose you have this kind of a thing, it's a flat array, right? Flat tensor. So there are 30 elements in it. As long as whatever you are sending here multiplies to like a by a multiplies by b, or a b c whatever you have, if this multiplication value is equal to the total number of elements you have, you can perform t dot reshape and it will reshape your value. All right, we can do another thing. Suppose t dot reshape 1. Suppose I know that I want 6 columns, or the first axis should be 6, but I don't know what will be my 0th axis. So what I can do is I can actually say -1 for whatever for the first 0th axis, and I can say 6. All right, and then if we print,
Pardon, I did not understand the -1, how it is
yeah,
functioning.
if you mention -1 in any axis, that means you are letting the package figure out what should be the number in that place, and your only focus is to have 6 in the second dimension.
The sixth column,
Yes.
6 is the column.
Yes, yes,
We want to maintain 6 columns,
yes.
and -1 be like a wide number, any number it will select.
No, not any number. So it is 6. 6 is fixed. You want 6 columns, but you don't know how, you really don't care how many rows gets created, right? So then you write -1 in this place, and PyTorch will figure out that you have mentioned 6 here and the total number of element is 30. So here you have to put -5, sorry, 5.
Suppose in place of 30 it is 43, then how it will do?
Then it will actually and then we'll have to see what will happen. 43 will
Yeah,
be, we
no,
can,
just I'm asking question how it will do, because everything is not multiple, otherwise it give error. It
yeah, it
cannot
will
be
give
transposed.
error. Most likely it will give error. Let's see.
It cannot be reshaped, is it, no?
Yes, yes. Let's
Okay.
create a sorry, let's
Correct.
put zeros. 43,
43, yes.
and then
-1,
it
yes.
will complain
Okay.
because it is not possible to divide by 6.
Okay, it will not work.
So if you are going to perform, so if suppose you want this kind of operations in your neural network, suppose you want a very your very custom neural network. So what you have to do is, if you are going to perform any kind of matrix manipulation, tensor manipulation, you should always use something like this: try and accept. This kind of fallback method should always be there if you are performing this kind of a thing, because it
Okay.
can break, right? Another,
So
yeah.
can we put the code also? Suppose take the parameter of we use 30, suppose zeros. The parameter of zeros we take and divide it by the what column we want to maintain, and take that number and put at the place of -1. It will work.
You can, yes, it will
Okay,
work.
fine. Okay. Thank you.
Another place will be, I will show you. So that's what you can do. So we use this kind of reshaping operation often in our neural network. Suppose you have a what you can say matrix or tensor, and you want to remove a value. So you can actually use torch.squeeze and you mention which value to be squeezed, right? If you do this, then actually it will it will be like kind of removed from this. All right. Or another application could be,
Then
suppose.
if we have two twos, will it remove only one element or
No,
more
no, this
than
is
one?
a second, like this will be the 0 1 2th element, right? 0 1 2.
Okay, it's index.
Yes,
So what
this
is
will.
a squeeze function? What doing with a squeeze?
We are removing a particular index value.
Okay,
Or
means the
suppose.
parameter is saying remove the second
Hmm, hmm,
twoth item from the T, right?
yes, yes.
Okay.
Another operation could be that, suppose your neural network is spitting out value in this format, two rows and one column, but you want it to be, so it's like a column matrix, right? So sorry, it's kind of row and column, but you want it only to be a row vector, column vector. So you want this output only to be in this format. Then what you do, you remove this index. That is also possible. We will show you
S,
an example of it.
S, squeeze one.
Yes.
Okay.
All right. We will see an example of it. Otherwise, if we don't do it, it will throw at us. I will show you an example of it. Then comes the mathematical operation, because ultimately your neural network is nothing but a giant calculator. So it has to perform matrix multiplication at the end of the day. Um,
Sir, will show
Are,
that example.
are you removing the codes also, sir? Whatever you are showing and practicing?
no, no, no.
And you
The
keep
code is
okay.
there.
Keep the codes also what we are asking so that we can go through that.
Sure, sure.
Uh, okay.
Sir, can you show that example of removing a diamond shape in the one which you said?
Sorry, I didn't get you.
Sir, you said we are changing the dimension of 2 cross 1, 2 cross 2, or 2 cross 3 to 2, only 2, like removing the columns.
Oh, I will show you the example later, because I'll have to show you the entire example. I have to run a network first, so I will show that at the end of the session. All right, just wait for that. I will show you.
Okay.
Yes, sir.
Sir,
Yes.
one more doubt.
Hmm.
In the changing the shape thing, can we do random thing in shape? Like we are not worried about the shape which we want, but we want to change the shape to a random shape out of those elements. Can we do it?
Why would you want that? Can you give me an actual, use case of it?
Yeah, sir, I should think about it.
The PyTorch exists for developing neural network, all right, and neural network is very strict about these dimensions. That's why whenever you perform any kind of, so if you are creating any tensor with any shape, these are very strict about this dimensions, all right. That's why this kind of random reshaping and all is not there. That's the kind of a thing. All right. Now suppose we have to perform the mathematical operations, right? Uh, and then what we can do is we can actually start performing um, just operations, just like we write in our papers. This is the this is the random tensor, right? So we can multiply this with 2, and then we can actually subtract 1 from it, right? So it will all be done in tensor format, so it's like a matrix operation. And if I'll first print the t1, and then I'll also print the t2. So you can see that even though this is the T1, right? T1 is in this shape, 5 rows and 2 columns, and then I am multiplying it by 2. So 2 will be multiplied with each of the values. It's not like only one, it gets multiplied by only one. And then I'm subtracting minus 1, right? So minus 1 will be, subtracting 1. So 1 will be broadcasted to this particular dimension, and then element wise subtraction will happen. Just like we do in NumPy. The same kind of broadcasting will happen here.
So how is coming 5153 multiplied by 2 is approximately 1.02. Minus 1, so it should be 0.2, na? 0.02, na?
Oh, sorry, I thought of it. No, that's a separate thing. What I'll do is, suppose A1. No, I have made a mistake here. I thought I was doing it right. Now,
A1 is 5 by 2.
so now you can see 2 times A1 minus A. Minus
2 times A1 minus A.
all ones.
The what?
Oh, again I have made mistake. Sorry.
T2.
Sorry. It should be A1.
Printed A1, yes. And this is T1. T1, na, sir?
Yes, T1. So now you can see that we have 2 times A1 minus 1. So
The 2
first,
times is 1. Okay. Now it is okay. Right.
yes.
So,
So now we can actually perform this kind of operations as well, right? Then comes this kind of multiplication operation. So this is point wise multiplication, or you can say even Hadamard product. So point wise, this is the where is T1? T1 is this
and the normal means what? Normal means?
standard normal, your Gaussian distribution.
Okay. It will automatically do the normal distribution of that.
Yes, so you are passing the parameters here. So normal distribution, and if I pass 0 and 1, mean as 0 and standard deviation as 1, it will become standard normal. I can pass mean as any point and standard deviation, then it will be another normal distribution.
Okay. And suppose we don't put also, then the normal it will take 0 and 1 because
Yeah, the default
normally
is
mean.
0 and 1.
Okay, default. Okay. And size, why we are putting size? Because the size we are
We
giving.
want it to be 5 rows and 2 columns.
Okay. T2. We have to supply this
Yes.
5 by 2.
Yes. No.
Okay.
You can even pass any number here, and it will give you in that particular shape.
Okay, got it. This is output set, na? Size 5 by 2 is output set.
Yes, output size.
Okay, and whatever we are supplying to this, it will give in the output set, but it should match the column sizes, right? Whatever.
No,
Am I right?
here no. Here you can pass any size. Suppose I want 5 rows and 10 columns. That will also give me. That will also work. Because here there is no kind of restriction. I can have this in any format, any shape, any size.
Sir, print also T2?
Sorry?
Print T2 also, sir. Print T2 also.
Okay.
So that we can understand.
T2 also.
Print T2 also. Okay. A 5 by 10. Okay. It will automatically do like that.
Yes.
And keep 5 by 3, then it will come to 5 by 3.
Yes.
Okay, got it. Okay, thank you.
Then we can also do matrix multiplication, but in it's
Hello, sir. I had a doubt. The
yes.
previous one. So you did the torch dot normal. So what I read was the rand n function. It does the same thing. It gives you random values with mean of 0 and standard deviation of 1. So are those two functions equivalent? Torch.normal and torch.randn?
Random, I think, will give you always minus between -1 and +1, but torch dot normal gives you the ability to generate any normal distribution. You just have to change the mean and standard deviation, and you can create any
Okay,
sorts
we
of.
have the flexibility. I think it is uh, basically the same thing, but in random we don't have the option to change it.
Yes,
Normally gives
exactly.
us the option to change it. Okay,
Yes.
but thank you.
Then comes the multiply. Remember that this multiply is point-wise multiplication. So if you have all, suppose you want to multiply this tensor with this tensor, and you call torch dot multiply, then this value will get multiplied with zero point 0.5. This value will get multiplied by this, right? So that's how the point-wise multiplication will be happening, and you will get a matrix of the same shape, right? So immediately you can understand that to call torch dot multiply, the shape of both t1 and t2 should be the same, the exact same. Otherwise it will throw error, because it has to perform pointwise multiplication, right? There is another sort of,
Same. What do you mean by same?
yeah, I will show you. T1 dot shape, T2 dot shape. Oh, I have changed these things, that's why.
5/3.
Suppose
5 by
5 by
2.
3, let's keep it like this, 5 by 3, 5 and 3. So you can see
Hmm.
that the first tensor has 5 rows and 2 columns.
Hmm.
Here this has 5 rows and 3 columns. Now if I run it, it will throw error. The errors are not very easy to read, right? So you have to kind of sometimes understand what it is trying to say. Multiply will always expect the same shape, otherwise it cannot do my what you can say. So I will show you. This is the extra in column, right? Extra column that t2 has.
Hmm.
T1
Hmm.
ends here, so it cannot it cannot multiply anything with this with anything, so it will cause error only when the shape matches. Only when I change it to 5 2, the shape
But
will be
still,
the
I
same.
think how it will multiply 5/2. It will multiply how tensors in the matrix. It is not like a matrix. It is different.
See, uh, this is the first value, right, of t2, and this is
Yeah.
the first value of t1, right? I can
Yeah.
multiply this 2, and this will be my value. I'm not
Okay.
sure if I'm calculating it
Okay.
right.
Not. It is not like matrix. It is
No.
one-to-one calculation, right?
Yes, exactly. It's Hadamard
Okay.
product, pointwise
Okay. Fine.
multiplication that we are doing. The thing
Okay.
you are saying, matrix multiplication, that also we can do, but the argument is bit different.
Matmal. Okay.
This
It is
one,
only
yes.
multiply only. Yeah. Yeah.
This is the
That is.
matrix multiplication that we actually are always doing. We have learned in our linear algebra course.
Yeah.
Here
Yeah.
here the thing is separate. If you pass 5 these two metrics, then it will throw error, because
Yes.
this
Got
should
it.
match with the first
Got it.
initial, right?
Yeah. Point wise always has to be same. Right.
Then
Very
how can
simple.
we multiply t1 with t2?
Same shape is required.
We can just transpose it, right? T1 dot t and t2.
Yeah, after transpose, we can do that. No, but for transpose also, the shape should be like that. The
Yes, even,
column
yes,
n m into n, then n should match, right?
yes. Whenever you are calling matmul, the the last index of the first tensor and the
Hmm.
first index of the last tensor should match exactly. Otherwise,
Okay.
matmul will throw error. That is why
Got
I
it.
was saying, whenever you are going to perform any kind of this operation like matrix
Hmm.
multiplication, addition, subtraction, you should perform this kind of try and except.
If it is giving error, then it's right,
Yes,
right.
and then you can actually check. First, check if the dimensions are matching or not. If it is matching, then only you or if you don't want try except, you check the
Hmm.
dimension using if else whatever statement you want, and then you
Yeah,
can,
got it.
right?
One more question. Suppose T1, T2, and T3 is also there. The what multiplication will do one point to point? Three, all the three will be multiplied?
T1,
Yeah,
T2.
only two. T1, T2, T3 in the parameter we are putting of the same size. Then every point wise it will multiply all the three.
Yes, yes.
Okay, fine. Okay, please.
Okay, then we can actually that actually concludes the matrix multiplication and mathematical operations. Then we'll see split and stack operation. Suppose this is a tensor, and you actually uh, split it into three parts. All right. So 3 means that since it's a kind of flat tensor, you want 3 pieces from this T. You mention it, and then it will actually give you an iter. I'm not sure if you know iter. So it will give you an iterator object, and you can actually print all this elements separately. It is almost like reshaping the element, and since I want 3 chunks, so each of the chunk will be of shape 2. All right. These
And the object T splits will be an object of right.
hmm,
Of right. Each element of the T splits will be an object, right?
yes,
Which will have two, I think,
yes, because the
two
3
elements.
yes, correct.
Okay.
Another
Data type is float. Okay.
another example is another useful operation is concatenation. Suppose oh, these are zeros, right? Huh. So suppose this is one tensor and you have another tensor, and you want to concatenate these two. So you can actually mention across which axis you want to concatenate. Since it's a flat matrix, so sorry, tensor, you have first the ones and then you have two zeros, right? Another operation could be stacking. So suppose you have suppose you have two tensors that you want to stack and create a new weight matrix. So what you can do is you can just stack two column tensors, and you can actually get a 2 by 3 tensors. So this part I will not, oh, I will have to show it, otherwise I cannot. Okay, fine. So now we have actually seen fair amount of tensor manipulation. We can now proceed with model development.
Sir, here in the this torch ones in the stack, ones and zeros are having only one single rows, right?
Hmm.
Suppose it has rows and columns both in the ones or dimension is more than this, then how it will be a stack?
So you are saying,
3 by 2.
I will
Yeah.
change it. I will just
Another, yeah. Keep it both so that, yeah. 3 by 2 and 0G also 3 by 2, then it will do like that.
so it will actually add across the
Okay.
axis.
Okay, element by element it will, okay, a stack.
Yes.
Each element will be a stacked like this. If it is 1, axis 0, keep it 0, then it will add
Across zero.
horizontally. Okay. It will first put all the things. Okay, got it.
Okay.
First 3 by 2 and second one. Okay, thank you.
It is almost 9. I thought of
Sorry.
going
Sorry,
for.
sir.
No, it's fine. It's good that we had
Because sir, this is basic thing now. We are
it's good
new
that
to.
you guys are having doubts, asking your questions. I will quickly cover this part. You can also see the like
Yeah,
recording of
yeah,
it.
yeah. Please.
We'll now go to the model development part. This will also be helpful for your DL GenAI project course. Uh, so what we can do is we can create tensor. We can always create tensor, but while sending this tensor to your model, we need a systematic way of sending the data, because as I said, um, you have to those neurons, whatever neurons you had in your input layer, corresponds to your features, right? So you have to send those features to your model for every row, right? So just to make sure that there is a systematic way of sending the data, you have some utility like data loader. And another reason is data can be anything in deep learning. It could be audio, it can be audio, it can be image, it can be 3D data. So loading the data in each of this modality will be different, right? But but while you send it to your model, that pipeline should be the same, right? It should get data in row by row, and you should be able to send the columns to your model. That should remain the same regardless of the modality you have in your data set. That's why you want some kind of data loader. All right, so if you this is a simple torch tensor, and then we are going to send this to data loader. All right, we'll then see what happens. So right, this is a data loader, and then what you can say is data loader actually gives you, so it's a 6 if I print the T, it gives you this 0 to 5 elements, right? And then I have created a data loader element. So if I, so data loader gives you all the elements one by one. You can think of it like it is giving me every row of this tensor, right? Then you can actually print item. Suppose I have another row T2, oh sorry, so data loader will not work in that case. So another approach would be that this is your X matrix, your feature matrix, and T2 is your label, right? You want to you want to get X and Y's for every data point, right? Then you will have to create your custom data loader. We will see in next. All right, we have not defined it. Another reason is we can even define batch size, right? Suppose it's a huge data set, it has 10,000 rows. Instead of sending all 10,000 rows at once, what you can do is you can actually create small batches. It's a 6, it has 6 values, right? So I have created 3 as batch size. If I now do it, the first batch will have 3 values, the second batch will have another 3 values, right? This is
So it should match with the number of the items in the
yes.
sensor. Na? That's why only batch size should be a factor of that, right?
Yes.
Okay, okay.
This is the example that I was telling you before.
Sir, what is enumerate?
Enumerate is a Python built-in operation. So if you have an iterator object like a list or a tuple or something, that on top of which you can iterate over, then if you call enumerate, then it will give you all the elements one by one.
It will take the data loader as a list and take the length of that
Exactly.
and keep am I right? No? It will
Yes,
keep,
yes,
and
yes.
you use it at in the step of 1, right?
Yes, and
No.
this first value will be the index of it, and whatever you have in your iterator object will give you in the second
Sir,
argument.
what would be the logic behind enumerate? Would it be a for or while loop only? No?
Suppose you have your data points and you want to know how many data. Suppose you have your batches, right? How many which batch you are working on, that also you want to print, right? So then what you do is you mention how many, what should be the batch size, and then you iterate over it. And then if you then print the I, this I will correspond to the batch number you have. Alright. Then you can also create a data set, your custom data loader, right? Custom data set. I was talking about this particular thing. Suppose you have your data set X and Y, and you want to send this data to your model. You will actually have to create a dataset object like this, and this is the custom signature of it. You should have an init method, then you have a len method. Do not change the len because it should have this len method, and it should also have a get item method. This inside this get item, you will define how you want the data to be sent to your model. It will be, so suppose you use this, then your data will be sent in this format: x1 y1. In the second run it will be sent as x2 y2.
And the init function and length function should be default always.
Yeah.
Right.
Yes. Inside init you can actually load the data, and then actually len is the same. It will be always the same. You have to return the length of the
Length of that.
Yes.
And
And
what this data set is a class, no? Data set.
yes, this is the default class, dataset class,
And
you are
then
inheriting from.
what is joint data set?
This
The
is your
class of the
custom
class.
data. No, this is your custom dataset. You are creating your custom dataset, and you are actually defining how to load your dataset.
It is also a class, no? You are defining class.
Yes.
The
It's a
joint
class.
data set is a class. So
Yes.
again, you are taking parameter as a class also, data set class.
No. This is called inheritance.
Okay, inheritance. It will properties of all the data set. It will
Yes,
be used.
exactly.
Okay.
PyTorch has
Got it.
already defined dataset as a very basic dataset class.
No. Okay, sir. Forgot that, sir. Got it.
Fine.
Okay, please.
So here you are actually saying, if I give you a tabular dataset which has feature and label, how to load it, and inside it you are actually saying self.xidx will be your first value and self.yidx will be your second value. So if you then actually call enumerate data loader this, then you will get values like in this format. Alright, actually I have given an example here. Tx is the matrix. You can call it as your feature matrix, and ty is the label. Alright. Then I have actually passed tx and ty into my join dataset. You see, this is the init method, right? This is your x get mapped to self.x, and y gets mapped to self.y, right? This part is clear, right?
Yeah.
Then what I can do is actually I can create a yes. Then actually I am creating an iterator object. So I am passing this.
Your voice broke, sir. Once again, last line.
Yeah. So
After you use translate.
join dataset is not defined. Right now, I am just commenting out this part. So what I have done here is I have actually created a my custom data set, which will give me x and y for every data point, right? Now if I do this, for example, so I am iterating over joint dataset and I want to print all the examples. First let us print so So if we print the example, you can see that the first value will be my x and the second value will be my y. Right? Even I can do, now what I can do is, actually you will see the use of it. So my feature will be example of 0 and my target will be example 1. Right, and then I can actually multiply feature with my weight value and then I can calculate all these things, right? That's the reason of doing it. All right.
3x.
So it's already 9, so we'll have to stop now. If you have any questions, you can ask. And I will share this notebook where I have created a linear regression model uh, from scratch. This is the from scratch model, and then I have used PyTorch training logic. Sorry, some ready-made kind of layers that for building a model. So you will see both in this notebook. If you have any, just go through this notebook step by step, and if you have any questions, you can ask in the next session, or even you can use Discourse to raise your queries.
Sir, will you show that pincer in removing? You said you will show later.
Oh yeah, yes, yes. So this was the example that I wanted to show. If you have DL GenAI theory course project, you will see this as well. So this is one model audio classifier, and the model is actually this is the output layer. So this output has, so if I remove this quiz, then the shape of it is in this format. 200 by 1. Okay, so actually it is creating a row vector, do 200 rows, and actually the shape is 1. This extra 1 is coming, but whatever I have in this y, y is a simple column vector. All right, the shape of y is 200. So if I now try to perform any operation, it will throw error because it is not going to match. This shape is not going to match. That's why we have to actually remove this one. So what we are doing here is, we are saying squeeze the first index. The first index. Yes, the first index. So this will be removed and it will be changed to this shape. All right. I
Okay.
know it is not very clear. Since you are out of time, I cannot run this notebook. But if you are in DL GenAI
Then
project,
next.
yes, you will be able.
In the next set, in the next session, we will do that.
Yes.
After going to the notebook, next session we will do, right?
Yes. Yes.
Sir, are TA sessions generally of only 1 hour?
Yes.
Sir, can you share today's notebook?
Yeah, it
Yeah,
will be
sir.
shared in Discourse forum.
And okay.
I'll also
Could you
share.
share
Sir,
the Discourse link again, because last session also, okay, where all the resources will be there.
Yeah, there will be a new for a post for every session. I think I'm also sharing it in this session itself.
Collab.
Yes, the
Sir,
collab.
if possible, please share the links of previous session recording also, sir, because uh, starting we couldn't add the calendar properly.
Okay,
And
fine. I'll.
in dashboard, the main page it has previous term's calendar. And if we go to week 0, then we will get this term's calendar.
Okay, I don't
So I
have the
missed
link,
few sessions.
so all the live sessions and everything will be kind of arranged in Discord, so you can go through it. We are still doing it, so by this week, yeah, I think you can expect it. I have shared both the collabs in this Meet chat, so you can go, you can just check it. Any other questions before we close for today?
Sir,
Yeah,
in
sir.
next
Okay.
session, will we build ANN from scratch?
Yes, next Wednesday session will be a theoretical recap, and in next Thursday session will be a hands-on, where we'll build these models.
Sir, one request I will tell. So you are arranging the resources. Keep a Excel sheet of that date
Yeah,
wise
yeah,
and
yeah.
topic
Yes, yes,
wise.
it will be done.
Topic wise also, sir, because what will happen, because new course and new project we are doing the same, so it will be better to arrange where it is, where to go and see the, because we are attending all the course recordings, but searching the particular content is very difficult. So if
Okay.
you keep in Excel sheet whatever is doing in the other, I think this contents, so video recordings, collabs of the same date, recording with match with the collab also. So that we can go to the recording, open the collab.